This is problem number 2 from section 3.2. In this problem it says find the indicated derivative. So we're going to use the definition for the derivative, and we can call it y prime or dy over dx. But we know that that is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. We're going to take the function, plug in x plus h, so we end up with limit as h approaches 0 of 5 x plus h cubed minus 5x cubed, because that's the original function, over h. Now x plus h cubed, we need to multiply that out. That's going to be x plus h times x plus h times x plus h. And from our previous problem, we know that x plus h times x plus h is just x squared plus 2xh plus h squared. And we can get that by taking x times x times h times x, h times h. And then from that, we're now going to multiply it times the x and the h terms, so we get x squared times x is x cubed. X squared times h is plus x squared h. 2xh times x is plus 2x squared h. 2xh times h is plus 2xh squared. H squared times x is plus h squared x. And h squared times h is plus h cubed. Combine these together, we end up with x cubed plus 2x squared h plus 2x h squared. Actually, that's 3 of them. So I screwed that. That's x squared h plus 2x squared h. That's 3 of these. And there's 3 of these. Plus h cubed. So we can now take this and plug it in here for x plus h cubed. So we're going to get limit as h approaches 0, 5, we get x cubed plus 3x squared h plus 3xh squared plus h cubed minus 5x cubed all over h. So it's going to be the limit as h approaches 0 of 5x cubed plus 15x squared h plus 15xh squared plus 5h cubed minus 5x cubed all over h. Negative 5x cubed and 5x cubed cancel. So I'm left with limit as h approaches 0 of 15x squared h plus 15xh squared plus 5h cubed all over h. That's going to equal the limit as h approaches 0. Factor in h out of the top, we get h 15x squared plus 15xh plus 5h squared. H's cancel, and you're left with the limit as h approaches 0 of 15x squared plus 15xh plus 5h squared. And when you plug in 0, this term cancels and this term cancels. You're left with 15x squared. So the derivative for the function is 15x squared. So remember, this is the expression, this derivative is the expression for the slope at any point on this line here.